Hello, my name is Isaiah Weeks, and today I will be talking about my presentation and poster, which is about integrating traditional ahupuaʻa systems with modern engineering and a pathway to 100% renewable energy in Hawaii. Today, Hawaii faces the challenge of transitioning to 100% renewable energy while maintaining environmental and cultural sustainability. And this is because the islands rely extremely heavily on imported fossil fuels, and especially with the increased prices of fossil fuels as of now, switching to 100% renewable energy would be greatly beneficial to the economy and just to the environment and the earth. I currently live in Ward, which is part of the Waikiki ahupuaʻa. And in the past, this ahupuaʻa used to consist of wetlands, taro patches, fresh water streams, and fish ponds that would support the native Hawaiian life. But today it has changed greatly due to all the industrialization and urban development, which has changed the landscape. But the main thing is that the principles of the ahupuaʻa remain very important today. It's very important because with how the ancient Hawaiians used to live, they were able to support a unfathomable amount of people for how small their island was and how little technology they had, which was based off of just fully regulating and making sure they always had some sort of food and didn't overfish or overfarm. As from figure 1, it shows what my ahupuaʻa would have looked like back in the day growing taro in the wetlands in Waikiki, in the Waikiki ahupuaʻa. The proverb from my ahupuaʻa was "Ika wa ma'amua ka wa mahope," which means the future is found in the past. And this is very important because, especially considering the Hawaiian history, because it really shows how the Hawaiians were able to maintain their land, maintain their food, and do it all effectively without hurting the earth. And I think this is very important because with global warming today, it's not looking like we're gonna end up being able to support how our lifestyles are for many generations to come. And now I will get into my design, which, because I didn't do my weeks 10 through 12, my design won't be based off of the project we were supposed to do, but it will be based off of what I've learned through weeks 1 through 9, which is basically the design we worked on for learning the basics of the Aladdin AI and how to research on energy, see how energy can be saved, and calculate how much energy is expended. But I made a design which is a replica of scale of the McKinley High School building. I'm not sure which building it was, but it was one of the buildings there. And I added some trees and a bunch of solar panels on top, covering the entire roof, and added insulation to the walls, roofs, and windows. And then in figure 2, it shows the McKinley High School building with the show of trees of solar and energy generation. The testing I did was by running it through the AI simulator, which would use previous year's data to run through and see how much energy will be spent on AC and how much energy is saved based off of trees and solar panel and insulation. And in table 3, in figure 3, that's the table of the generations expenditure, or the energy generations and its expenditure. And my conclusion in future work is my next steps would be to work on weeks 10 through 12 and finish that and make a more realistic building that generates net zero energy. Some things I learned were that solar was the most efficient, then was insulation, and then trees, but it could vary depending on how affordable solar is for people. And based off of that, I would argue that roofing insulation could be more important than solar, or if you can afford it, and that giant trees would be probably a good alternative. My references are there, and then I would like to acknowledge Mr. Hanai because I wouldn't have known how to do any of these things, and I wouldn't have known how to do Aladdin or use AI correctly. And then I would also like to acknowledge Aladdin because my projects wouldn't be possible without them. Thank you.